Like always, I'll try and give everybody about 5 minutes before we get started. Just for like full disclosure, I still don't feel great. So if I have to leave, I might just like walk off camera to go use the bathroom. Though I got to admit, the other day when I woke up with a fever, I was freaking out and I was like, oh no, this is it. I'm dead. And then as soon as I threw up and I checked, I like Googled, I was like, is vomiting an early symptom of the COVID? And then when the answer was no, I was so relieved to vomit. Also, just a little bit of random stuff, I guess. Have any of you guys ever bought a video game from the Humble Bundle? I'll take silence as a no, but Humble Bundle is a really good website where they package a bunch of video games together, and right now they have $1,000 worth of video games for 30 bucks. And all of the money that you pay for these games goes towards COVID-19 stuff. And the way that it pays out is that if you look here, they'll give you little codes that you can use to redeem these to your Steam account. So it's not like you just download them and then you have a hard time getting them back. And the reason why I recommend it is that this Humble Bundle is crazy. It has like a bunch of my own personal favorite games and some games that I'm missing from my collection. So I'm probably going to pick it up even though I have a bunch of these. And I'll just like give out the spare Steam codes. But Into the Breach, Undertale, Hollow Knight are all amazing. The Witness is amazing. Super Hot is ultra amazing if you've never played it.
Ooh, it's really good on VR.
The VR version of that game is actually not the same game. It's a totally different game.
Oh, really? Oh, no.
Yeah, the stages are different. It's weird. But yeah, if you have a VR headset, get both the normal and the VR version, especially since we're about to head to spring break. Psychonauts is great, and it's about to get its sequel on VR. Pikuniku is brand new, so I'm surprised it's here. Super Hexagon is good. You probably have it on your phone. VVVVVV is really good. Yeah, all this stuff for 30 bucks. Plus, if you already have some of these games and not all of them, you can split it with a buddy and like just have one of you pay the 30 bucks, have the other person pay that person half or whatever, and then split up the Steam codes. Anyway, let's get to business. Sorry about not being here yesterday. I was too crappy feeling to even sit down at my computer. I was mostly spending the day like moaning at the toilet. For right now, I would like you to do item number 1, decompose this homie into partial fractions. 5x minus 7 divided by the quantity of x minus 1 cubed. I just want to take a chance to look at one of these more complicated setup ones before tomorrow's quiz. And then after we go over that one, I want to go over what's going to be on tomorrow's quiz precisely so that everybody knows and like what the rules of it are and all that good stuff. And then for the rest of this hour, I just want to answer your guys' questions from the last section homework, which of course, since we didn't have workshop yesterday, no late penalties will be given out for it. Just get it done before you go off to spring break. Same with the review, no late penalties will be given out for that assignment. Just, you know, wrap it up before you go out to spring break. And this hour will be yours to like get all your questions answered. I'll go ahead and take attendance and we'll get started now. Yeah, so for item number 1 here, we have a partial fraction decomposition, and the denominator is x minus 1 quantity cubed. So when it comes to this kind of setup, how many terms are we going to have in our decomposition?
Is it 3?
Yeah, we're going to have 3 terms in our decomposition here. Oh boy, you know, I'm sorry, give me 1 second. Taking attendance on this screen is the worst. I have to like, I'm sure I've complained about this before, but it sorts your names by last name in teacheries, and it sorts your names by first name in Zoom. Just the worst. Huh? Ooh. Okay. Yeah, so this one's going to have 3 separate terms in the denominator. So our first term for having a repeated denominator is it's going to be something over x minus 1 plus something over x minus 1 squared plus something over x minus 1 cubed. And each one of these is going to get its own unsolved coefficient. So each one of these is going to get an A, a B, and a C. So what's the next part of our partial fraction decomposition? Multiply out all
the denominators.
Yeah, we have to make all of the denominators go away. And that is to say that we're going to take both sides of this equation and we're going to multiply by x minus 1 cubed. So on the left-hand side, that's just going to give us 5x minus 7. And for each one of these, it's only going to destroy part of the denominator. So here, it'll cancel with one of the x minus 1s. So a is going to be multiplied by x minus 1 quantity squared. It's going to destroy 2 of these and leave over 1 x minus 1 in the numerator. So that's going to be plus b times x minus 1. And c over here on the right has the exact same denominator, yeah? And so that's going to cancel completely, giving us just a plus c. And now we're going to go ahead and look for correspondence by multiplying these guys through here on the right-hand side. And we're going to group everything together by the order of x that it has. So x squared, linear x, and then all of our constants also have to line up. So the first thing that we're going to do is we're going to expand this x minus 1 squared, and I'm going to multiply in this b. So I'm going to get that 5x minus 7 is going to be equal to a quantity x squared minus 2x plus 1 plus bx minus 1 plus c. And now I'm going to multiply a into all 3 of these terms. So this is going to be 5x minus 7 is equal to ax squared minus 2ax plus a plus bx minus 1 plus c. Now I'm going to rewrite everything in descending order on the right. So this is going to be equal to ax squared minus 2ax plus bx plus a plus c minus 1. And just to clean everything up, I'm going to go ahead and I'm going to factor out the x here in the middle, and I'm going to put parentheses around all of our constants. So this is going to be equal to ax squared plus x times the quantity of, well, if I pull out x from here and here, I'm going to get b minus 2a plus the quantity of a plus c minus 1. Okay, so are there any questions there?
And Mr. Robinson, why did you put the parentheses over a plus c minus 1?
That's a good question. Again, what we're looking for here, the thing that makes these systems solvable is the fact that we're relying on correspondence. So this is a constant, this is a constant, this is a constant. The reason why I put this in parentheses is that this must be -7 because that's what my constant is on the left.
All right.
Excellent. So let's go ahead and use correspondence. One of these values is instantly clear to us. Look at this, ax squared. How much x squared is there on the left?
None.
None. So that means that a is 0 right off the bat. This guy must be 0 if there is no x squared on the left. So a is 0. And then this right here, b minus 2a, what does this have to be equal to according to correspondence?
5.
That has to be 5. So this is 5. And luckily, since we know that a is 0, that means that we know that b is automatically 5. Or for those of you who can't see it, 5 has to be equal to b minus 2a, where we just said a is 0. 5 is equal to b minus 2 times 0, which is, of course, 0. So a is 0. B is 5, and then this guy down here at the end can let us solve for c. So again, -7 is going to be equal to 0 plus c minus 1. I'll go ahead and add 1 to each side. -6 is equal to c. And now that we have all three of our unsolved coefficients, writing our partial fraction decomposition is nice and easy. This was our initial setup, and now I know that a is 0, b is 5, c is -6. So that means that this guy must be equal to 5 divided by x minus 1 squared minus 6 divided by x minus 1 cubed. Are there any questions on our partial fraction decomposition in the warm-up?
Mr. Robinson, when you distributed b, why didn't you multiply it to 1?
Oh, no.
I was just about to say.
Oh, yeah, because I'm still, like, tired and I haven't eaten in 30 hours. Okay, so yeah, we have a typo, but, you know, I'll go back and fix it. So for those of y'all who didn't notice, there was a mistake here with b. b gets multiplied into x and into -1. So that means in this line, this is actually bx minus b. This is also actually bx minus b. So that means that this isn't a plus c minus 1. This is a plus c minus b. Is that correct so far?
Yeah.
So then this becomes a plus c minus b also. B doesn't change. This will still just be 5. The only thing that it affects is that instead this will be -7 is equal to 0 plus c minus b. And if b is 5, that means c is
-2, right?
yeah, -2. So that means that this is -7 is equal to 0 plus c minus 5, and then we add 5 to each side, and that means -2 is equal to c. Hey, even though that mistake happened way lines above, that was actually a lot easier to fix than I thought. Good catch. So that means that c is actually -2. I am sorry for that. Okay, so let me talk to y'all about tomorrow's quiz, and then I'll just take any and all questions either from 9.4 or from the review. If I just spent the rest of this hour doing homework, that would be great. Here's the deal with tomorrow's quiz. It's going to be a regular class time, and it'll be on Zoom, and that's just so that I can answer your guys' questions if you have them as we go along. Though you guys aren't that talkative during tests and quizzes, like I don't get that many questions, so I doubt it'll be that chit-chatty, but still, I want everybody on Zoom while y'all take it. The quiz, let me grab it. The quiz that I wrote for y'all tomorrow is 11 questions. And here are the 11 questions that I'm going to ask y'all to solve. There are 3 systems of 2 linear equations. There are 2 systems of 3 equations. There are 2 nonlinear systems. There are 2 nonlinear inequalities. Which of the nonlinear inequalities, those are of course graphing questions. So I recommend that you have a ruler or graph paper is not necessary. I don't want to like make y'all purchase a thing just to do this quiz. If you have graph paper, it's nice, it's not necessary. Feel free to use a ruler, and I gave instructions on how to use your ruler and with reminders so that your graph is nice and clean. And then at the end, I have 2 PFDs, 2 partial fraction decompositions. And since we didn't have time for workshop, I made them, I wouldn't say easy, but they're not crazy. They're not like the last 2 in the homework that create some pretty complicated systems. And then the final question is a bonus. And I'll just tell you what the bonus question is right now. The bonus question is, what goals or projects are you going to work on over spring break in order to fill your time? I just want to make sure that y'all put some thought into it so that you're not, you know, mind-numbingly bored next week. Just tell me about what your plans are for spring break, and that'll net you 3 bonus points. Now, like, since it's a take-home, I'm not going to try and pretend that you're not going to use the internet, which is why I'll warn you, I will be grading the work methodically. I'm barely going to look at the answer because I basically expect everybody to get the correct answer for each one of these. But you do need to show that you understand how to solve the problem by providing the correct work. If you give me the correct answer, but there's no work provided, I'm going to know that you just fed it to Desmos or fed it to Symbolab or fed it to Wolfram Alpha. And even though doing that will produce the correct answer, it will yield you 0 points. The way that I'm gonna like keep y'all honest is by grading the work. Yes?
For a grading question, I mean for a graphing question, is there really work to do? Because you're given the graph. You're given
No, you're not given the graph, you're given the functions.
Yeah, but don't you just graph the functions?
Yeah, but the deal, what's the deal with nonlinear inequalities? How do I like check?
Let's see where we shade in, and then
Yeah.
also the dotted lines versus the solid lines.
Well, that's what I'm trying to say.
That's what's actually being graded, is whether or not you
Oh.
shade correctly and whether or not you give dotted or solid lines correctly.
Okay.
No, it's a really good question.
Right.
And I know this is weird because this is your guys' first take-home test, but yo, in graduate school, most of my midterms so far have been take-home. And yeah, the thing that they do is they grade your work, not the answer, because you know you could always Google it up, you could always use some kind of solver, but the thing that keeps you honest is the fact that you need to show the work.
Right.
Oh, and the other thing I'll warn you about is that you have 10 minutes after the period ends to upload it. After that, I take off a point per minute. A lot of people who did a quiz for me in geometry thought that 10 minutes was an extra 10 minutes to work, and then they lost points when they uploaded it late. Make sure not to do that.
Mr. Robinson,
Yep.
can we have an equation card?
I mean, no,
What the
it's open note, right?
The
Like
heck?
you have all of the notes that you took over the past few weeks along with you while you do this. So, I mean, if you want to make an equation card just because you're used to doing that, if it's a thing that you do to help you get ready for quizzes, power to you.
Loaded this guy.
But yeah, you don't have to turn it in or anything.
Okay.
Equation
Mr.
card.
Yeah.
So basically, you're just gonna upload the PDF of the quiz like on Classroom, and we just have to take a picture of like basically like we do with homework. Like
Yeah. Mm-hmm.
okay.
Yeah, at
Yeah,
the end, you'll just upload it to an assignment. It'll be called Chapter 9 Quiz. You don't have to print it out, but it is formatted like one of my normal tests. So if you like working on it in that format, feel free to print it out and upload it that way, but I'll take it either way. Just make sure that if you are just doing it on separate paper, number everything clearly and box your final solution to make it easier for me to grade.
Okay.
Okay, so it's fine. Just do it on paper and then take a picture.
Yeah.
Okay, definitely. Okay. Thank you.
Yeah, and like I said, I'll remind everybody again tomorrow, show all of your work is the most important part.
Sounds good.
Are there any other questions out there about tomorrow's quiz? Last thing that we do before we head out to Easter break? No? Okay. Are there any questions that I can answer? And let me start off with questions from the 9.4 homework. Are there any questions there?
Yeah. Yeah, Mr. Robinson?
Yeah.
Yeah, for questions like 13 or 15.
Okay. Give me 1 second. What page is the homework on? I'm on the PDF, but I'm like scrolled way. Oh, never mind. I'm on. Okay, sorry. What's the question?
Yeah, for questions like 13 or 15 in the homework,
Okay.
where it gives you like one term in the numerator.
Yeah.
Do you equal one like for instance like number 15?
Here, I'll just do one of them. Do you want me to? Because in my opinion, they're basically the same question. They only differ by numeric values, but the structure is the same. Let me do 15.
Yeah.
Mr. Robinson, can you scroll up the page a little so I can screenshot the quiz? What's on the quiz?
Three, two, one. Okay. So 9.4, number 15. So yeah, here's how we do number 15. 6x divided by x squared minus 4. First thing I need to do is I need to factor that denominator. That denominator is a difference of squares. So this is going to give us x minus 2, x plus 2. Both of these are linear, so both of our unsolved coefficients in the numerator are just going to be letters. And I'm tired of using a and b, so I'll use L and M. And now I'm going to multiply the denominator through to get rid of all of the denominators, which is going to give me 6x is equal to L times x plus 2 plus M times x minus 2.
Yeah.
And then I'm going to distribute through the L's and the M's. 6x is equal to Lx plus 2L plus Mx minus 2M. And then I'll group these together by power. So this is going to be equal to Lx plus Mx and plus the quantity of 2L minus 2M.
Yeah.
And now let's go ahead and factor out the x. So L plus M times x plus 2L minus 2M. So by correspondence, what does L plus M have to be equal to?
6.
This is 6.
6, yeah.
And how much constant is there on the left side?
0.
Yeah, 0.
0. So we could solve this as a system of linear equations or substitution, but I think this one's pretty intuitive. I need two numbers which add up to 6, but those two numbers are equal and opposite. Because I have 2L minus 2M, that's adding up to 0. This is implying that L has to be equal to M. So what are two equal numbers that add up to 6?
3.
They're both 3. L is equal to M, which is equal to 3. And then I can go back up to my decomposition. So this guy is 3, this guy is 3.
Mm. Okay, yeah. Thank you.
Any other questions out there from the section 4 homework? No? Even the like later ones, the harder ones?
Mr. Ramsey, could you do 33?
Yeah, gladly. The other thing that I would recommend, if y'all don't know, is that if you type in partial fraction decomposition solver, the first link you get is one for Simba Lab, which I think is excellent. And it shows you all the steps. Okay, 9.4, number 33. Yeah, this is the kind that I wanted to go over because this is what we were supposed to do in the notes yesterday. So I have the partial fraction, I'm sorry, the total fraction, negative 2x squared plus 10x plus 4 divided by the quantity of x minus 1 times x squared plus 3x plus 8. And the deal with this quadratic in the denominator is that this guy has a negative discriminant. If y'all think back to the discriminants in quadratics, it's b squared minus 4ac. And if that number ends up being negative, that means that that quadratic doesn't have real roots. So this is irreducible. This doesn't factor, nothing. This is going to be one of the denominators in our partial fraction breakdown. So this is going to be equal to something divided by x minus 1 plus something divided by x squared plus 3x plus 8. Now, the last item of notes, and like I said, we did this in the notes on Monday, but we didn't get to go over an example, which I don't like that, right? This guy has to get a special numerator. So this guy is degree 1, and the rule about partial fractions is that our numerator is always 1 degree lower. This is degree 1, which is why our numerator is just a letter. It's just going to be degree 0. What degree is this?
2.
Okay, 2 minus 1 is 1. And what does a degree 1 equation look like?
Isn't it
It
two
has,
letters?
it has a variable. It has a
Yeah.
like some kind of x.
There's a constant.
It's a line. You're all
It's
saying the
like-
right thing, but yeah, it's a linear equation. So this has to be bx plus c. So now from here, after that setup, the rest of it is the same. I'm going to multiply through the denominator to make it go away everywhere. So on the left-hand side, I just get negative 2x plus 10x plus 4 is going to be equal to a. And when I multiply in the denominator, the x minus 1 part will cancel, and a will get multiplied into the quadratic. And then when I multiply in the denominator, the quadratic will get canceled, and bx plus c will get multiplied into x minus 1.
Wait, Mr. Robinson,
Mm-hmm.
can you explain how you got bx plus c again?
The numerator term always has to be 1 degree lower than the denominator term. So here, when it's linear, right, this is degree 1, we subtract 1, and that's why these numerators are constants. But if our denominator term is quadratic, our numerator term is linear. It's degree 2, degree 1. This was the last item that we did in notes on Monday, but we didn't get to do an example. So if this is looks new to you, that's why.
Okay, thank you.
Mm-hmm. And then like I said before, the rest is factoring this out and then using correspondence. So this is going to be equal to ax squared plus 3ax plus 8a plus, and then over here, this all gets FOILed. So this is going to be plus bx squared, first outer, minus bx inner, plus cx last, minus c. Before I move along, could I get you all to double check my work? I don't want to make another mistake and have to go backwards. 1, 2, 3. 1, 2, 3. Okay. 1, 2, 3, 4. Okay, yeah, looks good.
Yeah, looks good.
And now we're going to group it up by degree so that we can use that correspondence principle. So this is, well, the correspondence principle is something else. That's a discussion for a different day. Nonetheless, we'll group up the x squareds. So that'll be a plus b x squared. And now we'll go ahead and group up everything with an x. So that's going to be 3a minus b plus c. So this is going to be plus 3a minus b plus c times x. And then we'll group up all of the constants, which is just going to be plus 8a minus c. Is this okay?
Yep.
Okay.
Yep.
So by correspondence, what does each one of these things equal to?
The negative 2x. So it would be 2.
This is negative
Or
2. This is
negative 2, yeah.
10.
10. And this is
4.
4. Yep. Because all we're doing is we're saying that if this equation becomes this equation, then the x parts have to force it to line up along those terms.
Right.
So now I have a system of 3 variables, 3 equations, and the best way to approach that system, in my opinion, is always by elimination. So I'm going to rewrite it on the next page here. So this is going to be a plus b is equal to negative 2. 3a minus b plus c is equal to 10. And 8a minus c is equal to 4. And so, like always, we're going to have to do a little bit of elimination in order to tangle this stuff apart. So here's what I'm going to do. Oh, no. Oh, man, I'm wearing white jeans. I just got pen on my white jeans. I'm so disappointed. You know, whatever. It's not like I'm going outside for months anyway. Nonetheless, I'm going to take these bottom 2 equations and I'm going to add them together. By eliminating c, that'll produce for me an equation which is only a's and b's. And then I can mix that together with the first equation to solve for a and b. So equation 2 plus equation 3, adding these guys together, is going to give me 11a minus b is equal to 14. Is that okay?
Right.
Yep.
And then I'm going to add this together with the first equation, and that will eliminate b. So if I do that, I'll do a plus b equals negative 2 plus 11a minus b is equal to 14. Add these guys up. B cancels b, and this gives me 12a is equal to 12. So therefore, a is equal to 1. And once you have one of the numbers, the rest of them fall into place. So if a is equal to 1 and this top equation is true, that means b has to be negative 3. So that's going to give me 1 plus b is equal to negative 3. I'm sorry, equal to negative 2. Subtract 1 from each side, b is equal to negative 3. And now that I have a and b, we'll take an equation and solve for c. I guess we'll just take this bottom one. So then that means 8 times 1 minus c is equal to 4. So then negative c is equal to negative 12. So therefore, yeah, c is equal to 12. So we go back to our original equation and we write these in. So that means that our partial fraction breakdown here is that a is 1, b is negative 3, and c is 12. Is that okay for question number 33?
Yep.
That is definitely the hardest one. And just so y'all know, there won't be one that is that complicated on the quiz. There is one where there's a numerator that you need to know to write as being linear. There is one question where the denominator has an x squared, but it's not this involved. I made the numbers much tighter.
Mr. Robinson, do you mind scrolling to the work or the other side?
Yeah. So back to where I solved the linear equations.
For the C, isn't it 4?
Assuming that this equation is true, 8a minus c, this is the constant. This is what's equal to 4. And after we find out that a is equal to 1, this is saying that 8 minus c is equal to 4. So for that to work out, c has to...
Yes, 4.
What is?
8 minus 4 would be 4. 8 minus 12 would be negative 4.
Oh, here.
No,
So this is 4 minus 8. So this should be negative 4. Yeah. I see what you're saying.
And C equals 4.
Yeah, so this is negative 4. Yes. So negative c is equal to negative 4, subtract 8 from each side, and then divide both sides by negative 1, c is equal to 4. That means in our partial fraction that this will be negative 3 plus 4. I thought it looked weird, man. That's why I took a second on it. Yeah, thank you. Okay, and I guess since that was the hard question from 9.4, that's probably the end of that. Are there any questions from the review assignment?
Mr. Robinson,
Yes.
number 3 and 4, without even solving, are they no
Yeah.
solution through elimination?
I'm kind of tripping over those questions.
Number 3 and 4, I got no solution for both, but would both be no solution?
I think 3 is, but 4 isn't.
Yeah, before you multiply the top one by 2.
Yeah.
Give me 1 second.
Everything.
Scrolling down.
Oh no,
to
Chris.
Hmm.
4 would be 0 equals 0.
If it's
There's
0
a
equals 0,
solution.
that means it's infinite solutions.
Then yeah, number 4 is infinite solutions then.
Wait, so then how is number 3 no solution?
Because it's 0 equals 18. Because you're multiplying the top one by 4.
So this is page
Oh, right.
861, the practice test, right?
Yeah, 861.
Yeah, I got actually, yeah, I see my mistake for number 3, but for number 4, I don't understand.
Yeah, number 3 I got, but number 4 is just tripping me out too.
Yeah, number
Is it
4 is
infinite?
infinite solutions. Both of those
Yeah.
equations are the same thing.
Yeah, it's 0 equals 0.
Yeah, which means infinite solutions. That means every point that you could plug in for x will satisfy.
Mr. Robinson, how would we write that down like arithmetically? Because like for example on Slater it says x is equal to 1/5 of the quantity of y plus 1.
Yeah, so that means that there's an infinite number of solutions, but you have to indicate that the infinite solutions lie along the line.
Oh, okay. So it's giving the line where they overlap.
Yes, which is either one of those equations. So for 4 from the review, you do the work and you get 0 equals 0. And here are like the ways that I will accept this answer. Infinite solutions is good, but not the best possible answer. Here's what is the most pedantic answer. All points along, and then just give one of the equations. So you could say all points along 5x minus y is equal to 1. Or if you're feeling like being a fancy lad, you could write this in y equals mx plus b and say all points along y is equal to negative 5x minus 1. Or anything which is equivalent to this.
Okay. Cool.
Yeah, or whatever, because there's an infinite number of ways to write the equation for a line.
All right, thank you.
That makes sense. Chris, did you do 5?
I'm doing it.
I muted everybody's microphones because it sounded like somebody out there was filing papers. Which, like, don't get me wrong, you know, stay busy. I got to get a green screen so I can make the most of these virtual backgrounds.
Mr. Robinson,
Yeah, what up?
can you also do number 5, please? Or any of the three system of 3 equations?
I'm still working on 5.
Yeah, I'll do 5, yeah. And like most things, I think the smartest approach is to start off by nuking all of those fractions. Start off by multiplying by all denominators. So I'm actually going to do that before I start working. Also, before I start working, give me 1 second. This is my last sheet of white paper. Underneath this is my graph paper. Give me 1 second. I was planning on doing all of my at-home notes on graph paper, and I still don't really know why. I'm sure it's just because the camera's low quality. It just looks like garbage. It's really sad. I like bought all this graph paper. I was like, oh, if I'm going to be lecturing from home, I should do it on graph paper. And it just looks like junk. Anyways, review 5. Okay. So before I start into it, like I said, I'm just going to multiply through those denominators because multiplying by a constant is one of the valid steps that you can do when you are solving a system of linear equations. We only have 2 options. We can either multiply by constants or we can add 2 equations together. Those are the only steps you can take, but those steps are sufficient to solving these questions. So I'm going to, before I rewrite the first equation, I'm going to multiply it by 10. So that is to say that 40x minus 60y minus 20z is equal to 1. Before I write down the second equation, I'm going to multiply it by 4. So that's going to give me 4x minus 28y plus 20z is equal to -1. And then that third equation, I'm going to multiply it by 5. So 15x plus 30y minus 45z is equal to 6. Is that okay as a first step?
Yeah.
Okay. Mr. Robinson, just to clarify again, we don't need, we can set equal any of the variables. Like for example, we can set equal x.
Sure, yeah. Because what we're doing, what the logic is to solve these is there's no straightforward way to solve a system of 3 linear equations, but as long as you have 3 equations, you can use them to eliminate one of the variables. And then instead of solving 3 equations, 3 variables, it makes it into 2 variables, 2 equations instead.
Okay.
Wait, Mr.
So,
Robinson?
yes.
You multiplied the second equation by 4.
By 5, because, oh, the second equation, yeah, by 4.
Okay. Shouldn't the -1 be -4?
No, because it's -1/4. -1/4 times 4 is -1.
Sorry, yeah, I didn't see that.
Yeah, that's the point, is to get rid of the fractions. So, I mean, I believe the easiest way to do this, though I guess the fraction stuff is unavoidable if we're gonna, trying to see if there's like a nice clean way to do this, but it seems like no matter what variable set we're gonna use, we're gonna have to eliminate,
Yeah.
with some fractions in there. I think z is probably the cleanest, only because 45 over 20 is 9/4.
Mr. Robinson, this is from the review or the practice test?
The practice test,
861, Chris.
yeah, that's what I assigned, right? Is the first few problems on the practice test.
Right.
Yeah.
Yeah.
Wait. Wait, mine is different in my book. Wait, this is
861?
Yeah.
That's weird. Do you have the physical copy?
Practice test, Rog. I mean, Chris.
Yep.
Oh,
Practice test 861.
are you in the physical copy of the book?
Yeah, yeah.
Oh, where the digital copy gets updates. Which is the weirdest thing
Oh.
about this book being open source and on the internet. So you have a version of the book that's probably a year old or so, but the online version is constantly being updated. So they probably had a typo in the printed version in the book. Either way, it's good practice. You know?
Mr. Robinson,
Yeah.
this is after you multiplied, right?
Yes, I multiplied out all the
Like
denominators so that it would be easier to look at.
Oh no, then it's the same. I thought this was before you multiplied.
Oh, okay. That
Yeah,
explains the
no,
mystery.
it's the same.
So
Okay.
because these two are already lined up, I'm gonna force this one down here to match so that I can eliminate the z's, and then we'll just be solving these two equations for x's and for y's. So I'm gonna multiply this third equation by -4/9, which is going to have the nice effect of turning 45 into 20. But it is going to produce some fractions potentially. But luckily, we live in a world with calculator. So I'm going to do 15 times -4/9. So this is going to give me -20/3x plus that should be negative, minus 40/3y plus 20z is equal to -8/3. So this is just where this is equation 1 and 2 and 3. This is just a rewrite of equation 3. Is that okay?
Then we would just combine equation 2 and 3, right?
We would combine equation 1 with equation 2. We would also combine equation 1 with equation 3.
Right.
Yeah, we're doing elimination so that we can reduce this from a system of 3 variables and 3 equations down to 2 variables, 2 equations, and then from there solving it is easy. So I'm going to do equation 1 plus equation 2. So this is going to give us 44x minus 88y. The z's eliminate, which is the point, and this is equal to 0. Oh, actually, this system's really easy to solve. Nonetheless, and then equation 2 plus this modified version of equation 3. Yet again, I'm going to have to rely on my calculator because, like, we could do a bunch of stuff with mixed fractions, but why do that in a world where our calculators have a math frac command? So our second equation set, equation 1 plus equation 3. This is going to give us -8/3 x. And then it'll be -28 minus 40/3. This is going to give us minus 124/3y, 20z, and I'm sorry. Oh God, my brain is so dumb. I'm so sorry, kids. I'm still not feeling my best. Did anybody see the terrible mistake I made, or is everybody just doing their own work? I added equation 2 to equation 3 instead of adding equation 1 to equation 3. So this should be 40 minus 20/3. Which gives us 100/3x. And then it'll be minus 60 minus 40/3. Which gives us -220/3y is equal to 1 minus 8/3 equals -5/3. And the point of that was to eliminate the z's with each other, -20z and +20z. So then from here, this is just 2 systems, 2 equations. Multiply this homie by 3, and off you go. Is that okay?
We multiply the second equation by 3?
Yeah, just to get rid of the denominators, and then you need to line up either 44 with 100 or 88 with 220, or just substitute in order to solve for x and y.
Mr. Robinson, would it be easier to substitute or eliminate for that?
When you're doing two linear equations, I think it's the same difficulty. I think it's irrelevant at that point. Maybe because these guys don't have obvious multiples of each other, maybe it would be smarter in this case to just substitute and brute force the math.
Isn't x equals 2y?
Yeah, x is equal to 2y in this case. And then that's probably easy to substitute in. Oh, that's why. That sucks.
Mr. Robinson, quick question. You can't use substitution for three system of equations, right? Like for number
Oh,
6.
you could. Yeah, it's just that it's extremely difficult and extremely time consuming. What you would
Yeah,
need to
because
do is you would need to take one of the equations and solve it for x. You would need to take the other equation, solve it for y. You would have to take both of those, plug it into the first equation, and then that would allow you to solve. It sucks. I wouldn't do that if I was you.
yeah, okay. Yeah,
And
because I don't know
yeah.
if you can see it for number 6. Like you just like for the last equation, you just multiply by 2 and it all becomes equal to 20.
Yeah. I mean, the other reason why I'm having you guys do elimination is that these operations that we have where I can multiply a line by a constant and I can add that line to another line. When we get to the second half of this chapter, after we come back from spring break, that's basically all we're doing, dog. We're going to be talking about matrices, but these operations, multiply a line by a number, add one line to another line, that is basically everything we're doing for the second half of this chapter. We're just going to learn fancier and fancier techniques that let us utilize that.
All right.
Did y'all do matrices in Algebra 2, or did that get skipped?
No, we did that.
Yeah, we did some.
Hey, Mr. Robinson,
Yeah.
for number 5, for x and y, I got the right values, but I plugged it in for z, and I'm getting 1/4 instead of 1/5. I'm looking at the back of the book for the answers. So I got x is equal to half and y is equal to 1/4.
Give me 1 second. 1 second, yeah. Okay. Well, let's go ahead and check by the laziest way possible. So 4x minus 6y minus 2z is equal to 1 over 10.
Wait, Mr. Robinson, I didn't put in that equation. I put in 40x minus 60y minus
It
20
doesn't.
is equals 1.
Doesn't matter. And then that third equation is 3x plus 6y minus 9z is equal to 6/5. That should be the answer. X is 1/2, Y is 1/4, Z is 1/5.
I don't get what I'm doing wrong in my algebra.
I sadly cannot help you unless I can see your algebra. Yeah, just double check. Were you doing the common denominator stuff by hand, or were you using your calculator?
And
Yeah, you probably just lost a common denominator somewhere or got the wrong numerator when you multiplied to get a common denominator. Don't get me wrong, being able to play with fractions is important, but the math frac button on the calculator will save you a ton of lost credit over the course of your college career. Highly recommended. Anyway, y'all, that is the end of class. I'm sorry I had to dip yesterday, but like I said, tomorrow we have our quiz. If you have any questions between now and tomorrow, just shoot me an email. Though I think like the stuff on the quiz is pretty straightforward, and I didn't like show y'all this Google window just for no, I mean, sorry, this Wolfram Alpha window for no reason. Taking take-home exams is fundamentally different. You get to be comfortable in your own home. You have all of the resources available to you that you know how to use. You know exactly what's on the quiz. And like I said, what I'm actually grading is the work. So make sure tomorrow that you are very explicit in the showing of your work. Best of luck to you, and I'll see you tomorrow morning.
See you, Mr. Robinson.
Thank you, Mr. Rob.
Yep, peace.